Let's see how the luminosity of a star will change if its mass is increased from 2 solar masses to 5 solar masses. Originally, it's at 2 solar masses, so let's see how luminous it is right now. We'll use the mass-luminosity relation to determine this. So we have the luminosity of the star over the luminosity of the sun proportional to the mass of that star over the mass of the sun, cubed. But anytime our equation isn't using an equal sign, but rather uses the proportionality symbol, we can throw in a constant, call it C for constant, though it doesn't really matter what letter you choose, and we can replace the proportionality symbol with an equal sign. This makes the rest of the math more familiar. But we can also make the rest of the math easier by just setting this constant equal to 1 so we don't have to worry about it. So this is the equation we'll use. We know the mass of the star is 2 solar masses, so let's plug that in at the top of the mass ratio. And the units of solar masses cancel out. Great. So now we're just left with a 2 in the parentheses on the right, and when we cube that 2, we get 8. So this star is originally 8 solar luminosities, meaning it is 8 times as luminous as the sun. But what happens now, though, now that the star's mass has increased to 5 solar masses from its original 2? Well, let's calculate its luminosity now and see how much more luminous it got. Again, we'll use this version of the mass-luminosity relation, now plugging in 5 solar masses at the top of the fraction on the right. Again, the units of solar masses cancel out, and we have 5 cubed, which is 125. So now, the star has become 125 times as luminous as the sun after its mass was increased. So let's compare. Before, this star was 8 solar luminosities. As it gained more mass, it became 125 solar luminosities. To find out how much more luminous it itself got, just divide the new luminosity by the old, and we'll see that the star became almost 16 times more luminous.